Hello and welcome. In this video, we'll solve some of the problems on the concepts we discussed in the previous video. The first problem we have, we need to find the number of onto functions from A to B. If n of A is 6 and n of B is 3, so we have n is equal to 6 and m is equal to 3. So we know that number of onto functions is equal to summation r is equal to 1 to m minus 1 power m minus r into mcr into r power n. So we'll substitute all the given terms. R is from 1 to 3 minus 1 power m is 3 minus r, m is again 3cr into r to the power of 6. So we'll expand this summation. Let us put r is equal to 1. If I put r, the summation starts from 1 and ends at 3. So we put r is equal to 1. So we'll get minus 1 power 3 minus 1 into 3c1 into 1 power 6 plus next we'll put r is equal to 2. So we'll get minus 1 power 3 minus 2 3c2 and 2 power 6 plus we'll put r is equal to 3 finally, minus 1 power 3 minus 3 3c3 into r is 3 power 6. So this is minus 1 square into 3c1. 3c1 is actually 3p1 by 1 factorial. 3p1 is 3 by 1 is 3. So 3c1 is 3 into 1 power 6 is 1 plus you get minus 1 power 1 3c2. 3c2 is actually 3p2 divided by 2 factorial. 3p2 is 3 into 2 divided by 2 factorial is 2. 2 and 2 will go, so we'll get 3. So 3c2 is 3 into 2 power 6. Let us keep as it is. Plus minus 1 power 0. 3c3. 3c3 is 1 actually. So it is 3p3 divided by 3 factorial. 3p3 is 3 factorial divided by 3 factorial. So 3c3 is 1 into 1 plus into 3 power 6. So minus 1 square is plus 1. We'll get 3 minus 1. So minus 1 to the power of 1 is minus 1. Get 3 into 2 power 6 plus 3 power 6. So we'll simplify this. I can take 3 common, get 1 minus 2 power 6 plus 3 power 5. So this is equal to 3 into 1 minus 2 power 6 is 64 plus 3 power 5. 3 power 5 is 3 power 3 into 3 power 2, which is 27 into 9. 9 7 to 63, 6 9 2 is 18, and this is 243. So it is 243. This is 3 into 243 minus 63. 243 minus 63. 243 minus 63. So we'll get 3 into 180. So 3 into 180 is 540. So option D is correct. Next problem we'll solve. So we have set A. Number of elements in set A is 106. We need to find the number of bijective functions from A to A. From A to A. From A to A, the number of bijection is actually n factorial, so which is 106 factorial. Option C is correct. Next we'll take another problem. Number of elements in A is 6 distinct elements we have. The number of distinct functions from A to A which are not bijection we have to find. So let us do this. We have set A which is let us take 6 elements, 1 2 3 4 5 and 6. 1 2 3 4 5 and 6 same elements. The number of bijections, we know that the number of bijection is actually n factorial, which is 6 factorial. So we need to find the number of distinct functions which are not bijections. So totally we have the number of functions is actually n power m. So here both n and m are equal, so it is 6 power 6. See, this is the total number of functions that we can form from a to a, and number of bijections is 6 factorial. So the number of distinct functions or 1 functions which are not bijection is equal to total number of functions is 6 power 6 minus number of bijection is 6 factorial. So this is the answer. Option C is correct. Next problem, we have set A containing 5 elements, set B, so this I can write n is equal to 5, and set B contains 6 elements, I can take m is equal to 6. Number of 1 1 and onto mappings. So number of bijection we need to find. Let's see how to solve this. We have two sets, A and B, A, B, C, D and E. 1 2 3 4 5 and 6. To make it bijection, I think the function should be both 1 1 and onto. So if I make 1 1, so I have to map every element of A to only one element of B. So when I do this, since the number of elements in B is 1 more than the number of elements in A, always all this 1 1 all this in all the 1 1 mapping, one of the elements in B will be unmapped, so which makes us to which prevents us to create onto function. So when we cannot create onto functions, this does not become bijection. So the number of functions we can generate, number of bijections we can generate from this is 0, because to generate bijection we should have both the sets should have the common elements, should have same number of elements. So here the number of elements in A is different than the number of elements in B. We cannot generate any bijections out of it. So option is C. Next problem we can solve is we have number of elements of A is n and B is 2. We need to find the number of surjections, right? Number of onto functions. The number of onto functions, you know that the formula is summation r is equal to 1 to m minus 1 power m minus r mcr into r power n. So we'll put the given terms. R is 1 to 2 minus 1 power 2 minus r 2cr and r power n. Let's expand by putting r is equal to 1. So I'll get minus 1 power 2 minus 1 2c1 1 power n plus minus 1 power 2 minus 2 is 0 and 2c2, and we have r is 2 now, 2 power n. So this is minus 1 power 1, 2c1 is 2, 1 power n is 1, minus 1 power 0 is 1 plus 2c2 is 1, 2 power n. So here I'll get minus 2, here I'll get 2 power n. So answer is 2 power n minus 2. So option is this. Next problem. So okay, we have two sets. A is x such that x belong to natural numbers and x is less than or equal to 5. So I can write A as elements from 1, 2, 3, 4 and 5, and B as B is actually the solution for this quadratic equation. Since we are finding the number of onto functions, we are not worried about the number of, we are not worried about the elements inside B, we are only worried about number of elements inside the B. So since we have quadratic equation, there are only two roots, so we can have two elements here. So I don't worry, I don't care about how what are the elements inside this B, because all I need is the number of elements in B. So n we have 5 and m we have 2. We need to find the number of onto functions, which is summation r is equal to 1 to m minus 1 power m minus r mcr r power n. So this is summation r is equal to 1 to 2 minus 1 power 2 minus r, m is 2 cr, r power n is 5. So if I expand putting r is equal to 1, I'll get minus 1 power 2 minus 1 is 1, 2c1, r is 1 power 5, plus, now let us put r is equal to 2, I'll get minus 1 to the power of 0, 2 minus 2 is 0, 2c2 into r is 2 power 5. So this is minus 1 into 2c1 is 2, 1 power 5 is 1, plus minus 1 power 0 is 1, 2c1 is 2c2 is 1, and 2 power 5. So I'll get minus 2 plus 2 power 5. This is equal to minus 2 plus 2 power 5 is 32. 32 minus 2 is 30. So option B. Next we have set x, which is set x containing 7 elements. So n of x is 7, n of y is 8. Number of bijections, the number of bijections that can be formed from x to y, so we can form bijections from x to y only when number of elements in x is equal to number of elements in y. This is not true, so we cannot form any bijections. The answer is 0. Thanks for watching.